All right. Good morning, everyone. And first, an order of business. Life is always interesting, so I have to make a disclaimer that my name is indeed Willie Soon. However, whatever that I have to say representing strictly myself and doesn't represent any other persons or institution in this universe. Well, just to follow up on Fred, really nice quote on Chairman Waxman. Some years ago, there's this famous environmentalist or climate expert by the name of David Suzuki from Canada, who literally says that the reason why you get warm inside a car with no window it's really the greenhouse effects of your CO2 in there. So this is really terrible stuff. But anyway, the three key messages of my talk, I'll walk you through some of the evidence, of course. Point number one, CO2 is definitely not an air pollutant. No matter how you want to say it, you first have to outlaw frisbee and flatulence, as Anthony Scalia would say. It is food for plants and marine life. No if or buts about this. Second point is this is aspect really especially important because we're talking about controlling carbon dioxide emission. The level of carbon dioxide, even if you emit 100%, it doesn't stay 100% in the atmosphere. It's completely controlled by temperature and other biological and chemical variables, not the other way around. So that's fairly important because we're now fighting about something that related to basically smoking cigarette, lung cancer causes cigarette smoking. So that's something that's really important for science. And then finally, there's absolutely no such thing as a magical CO2 knob that will allow you to adjust up or down, right? Unless you're Mr. Gore. But then in this example here, I'm going to try to, of course, illuminate a little bit about the role of the sun in the climate system. So let me proceed. First, let's look at what is happening. Okay? Here's the fact. The fact is that atmospheric CO2 has been rising. And it's been rising very rapidly. Okay? And guess, we all know that what? CO2 is a greenhouse gas. Everybody agree, yes? And we know that it produces greenhouse effects. And guess what greenhouse effect must do? It must only warm, yes? So what does the globe temperature is doing? Clearly, we're not suggesting that rising atmospheric CO2 or having more of this greenhouse effect is cooling the planet Earth. So you have only very limited choices of conclusion that you can make. The data is wrong, of course. But you really have a very clear statement here to say that perhaps CO2 is nowhere close to all these folks' statements about driving the whole climate system and predominantly even for the next 50 to 100 years, which is clearly a very difficult assertion to support scientifically, and it's really clearly flawed. I will not show the data that is very valuable. This is about measuring of the ocean heat content, but most folks will talk about it. Perhaps Locke Wanton will mention some of that in his speech. This is measuring the heat content of the ocean, which we do have some data now. It's basically based on float that is some 3,000 float across all the world ocean, sampling the ocean from the surface to 2,000 meter down. And we do have that very good data now for almost 2003 until now, and essentially showing you that the ocean heat content is not rising, it's not continuing to rise as is predicted by the model. So really having a real difficulties to support the CO2 warming hypothesis. And then of course, plenty other data to support that, and Professor Lindzen showed a very interesting contradiction between what is observed and what is being put out by the climate model, which is basically garbage in and gospel out. And now an important lessons in science, of course. Sorry that I have to say this, I'm no authority in science, but then Professor Albert Einstein is indeed a very serious thinker on this natural philosophy. No amount of experimentation can indeed ever prove me right, but a single experiment really can prove me wrong. Here comes the famous Iceman in Alaska, which is very well loved. Now, there's still those who keep saying, why don't we just simply restrict the human component of CO2 emission anyway? You know, it might cause some problem, you know? And as you know that they're very clever on their side, they're invoking not only Clean Air Act, they're invoking Clean Water Act, and I will not speak about the aspect about how the marine lives are being starved on CO2. Perhaps Craig Itzel will mention that in his talk. I will just specify the part on the plants, which actually also their work, which is by Professor Sherwood Itzel. Here I'm showing you a collection of some 280 experiments. Okay? The question is, why don't we simply restrict human component of CO2 emission anyway, just in case? But then if you take the experimental data that we do have, which is to study the plant response, which is the growth enhancement from 0 to about 200%, planting all these species and plants at 300 parts per million, 600 parts per million, and 1,350 parts per million. And the blue curve at the bottom there is under non-stress condition, meaning that the experimentation were done with unlimited sunshine and water and nutrients. And then the similar experiment is done for stress condition, which is much similar to the real world, where the water, sunshine, and nutrients are always limited. So we're kind of bending towards the upper end of it, okay? And what I show you is today's level of CO2, roughly 380 or 390 or so. Here's my answer for not really controlling the CO2 emission at all. Because what about the real threat to the CO2 starvation in plants? If you really want to consider food production is a good thing, increasing food production for feeding hungry people. So this is indeed the questions that I'm very concerned about. I did ask Mr. Gore about what will we get by cutting CO2 emission. I mean, he just simply refused to answer the questions. What about the threat to the people not having enough food? And he wouldn't, I guess he's not too concerned about that either. This is now a more vivid picture of, if you prefer plants to live under 120 or even 380, up to you. But I kind of prefer plants as living in a high CO2 condition where it's a biological fact that one cannot change no matter how the US Supreme Court wanted to label it as an air pollutant. CO2 is a good thing for plants. Sorry. Now I'm going to point to something that is maybe not so trivial, but then they did have a very huge powwow in Seoul, Korea. There was some kind of announcement, and Bill Clinton was there, keynote speaker. It was basically all this group of cities, mayors across the world, having this very ambitious plan. Really have nothing to do with any true governance, but then it's the city mayors going around adopting this UN Urban Environmental Accords. Essentially, one of the key things that they would urge every cities in the world to take action is to adopt this citywide greenhouse gas reduction plan that will reduce the emission by 25% by 2030. All right, and then of course, with the emphasis that the benefit of the decision will be, will be really very helpful if we have a critical assessment of data and alternative. And now we're going to go about doing a test on this, an empirical test. This is a phenomenon called the CO2 urban dome that is happening in all the world large urban city now. And mainly, it's related to, of course, the emission source of it. But then it's really mainly controlled by the ineffective CO2 sink during winter time and during nighttime, okay, where the biological sphere is not active. Now let me show you the data. This is one of the reasonable urban big city. It's Salt Lake City. It has really the best data collected. Okay? It goes from about, collected almost weekly or daily from about 2002 or so to 2009. And it goes up and down, up and down. What I plotted you is actually the free air troposphere's value of carbon dioxide level, which is 385 or so. I roughly put it there, or 390, doesn't matter. And every single time come the winter, when the biological sphere is not, surface is not active, is covered with ice and so on and so forth, you can see this rise in the atmospheric concentration. Some of the data point really went beyond not the roof, but really way up there, 600 ppm or so at least. And then in other cities, this thing can go as high as even 1,000 ppm. And so, guess what? We do now have an empirical test. All this mayor wanted to cut down all the CO2 emission. The point is to do what? Will we get any reduction of the winter temperature, right, in, let's say, Salt Lake City by itself? And this is just a pictorial proof to you that 2004, we indeed have all this urban condition. We pave our surfaces, we build cities, we build universities, and so on and so forth, and live our life as, as a productive citizen. And then here's 1870, Salt Lake Valley. Basically, the old condition. If you prefer to live in that condition, it's up to you. But here's now the test, of course. If you look at the winter temperature, okay, because the whole idea is that if you have extremely high winter CO2 in the current period, right, it's up to 500 ppm, and then in the past, let's say your level is really low, or roughly 300 or so, then you ought to be able to see these effects of winter temperature warming very rapidly in Salt Lake City. In science, I'm sorry again, it's always about, what is your hypothesis and what is the empirical data to support it or reject it? I mean, here's the way to look at it. I mean, I'm a very simple-minded person. the point is that I really couldn't find any winter warming in Salt Lake City. And I mean, please tell some of the mayors in all these cities, what are they actually trying to accomplish? I don't understand that for a minute. Oh, so I was so frustrated, so I went to a global warming rally. Oh, former Vice President. This is actually a Nobel Prize acceptance speech, by the way. But anyway, joking aside, forget about the iceman and the snowman, and now I'm not going to talk about something hotter, a little bit warmer. This is a picture of our sun, of course. It's the majestic science will supply all the energy to the climate system, essentially. And now, guess what's the proof? I mean, if you really want to look for some ideas, I mean, it is a very, very difficult subject, first of all. You first have to understand what the sun is actually doing. You first have to understand so many layers of how the climate system will really behave, including issues of climate sensitivity with respect to how much you change in your energy input to the system. I'm an empiricist. I'm not very good of a theoretician, but then I just look for the best data sets that I can find. Here I look into the Arctic region. The top panel to your left here is the Arctic as a whole. And then I have also 3 other sectors across the Arctic, which is Atlantic sector, the Pacific, and the Greenland, Iceland sectors. These are the available decadally smooth data. And then I also plotted the best estimate of the solar irradiance curve, the solar energy changes over that time. The correlation is really, really fairly impressive, and is quite consistent, not only on average as a whole, but then in regional basis. And then if you look even in further details, we know that Greenland was green before. The Vikings actually settled in places like even Gotthard, which is on the west coast. Of course, they settled, the main colonization is slightly more towards the tip of southern Greenland. But then Gotthard has some reasonable data record, which I believe is not contaminated by a lot of the problems that Anthony Watt is pointing out. Same solar curve, and then the temperature curve that is available for Gotthard. And then also on the east coast of Greenland, Ammassalik, you also have similar kind of hint. And this is the kind of criteria if you want to propose some kind of a solar irradiance forcing hypothesis, that it has to have a certain level of consistency. And note that if you try to attempt to describe all these changes, these multi-decadal to centennial changes that are variability of the climate system, especially in the Arctic, by CO2, I mean, I really think that the hope of explaining that is very, very low. Well, you could not come to Washington, D.C. without addressing the Washington, D.C. data record itself. As Anthony Watt has said, it is almost hopeless to try to get those data and try to figure out these effects of the urban heat island effects and all this paint job, whatever, all this problem. I haven't tried my best to look for the best available data record. This is actually Royal Oaks, Maryland, which is, you also have some picture on that. This is a slightly better remote rural area, some 46 miles from Washington, D.C. Again, just as a way to test for fun, to show you that, my irradiance reconstruction, and then the temperature curve. It's not bad, actually. If you smooth it by a decadal filter, it explains up to 70% of the variance, which is quite impressive. Okay? Clearly, that if you try to do that with CO2, you're not going to be anywhere close. All right? Of course, our job is still to fully explain what is it that is going on, right? Because all I've shown you so far, by the way, I do have a scientific hypothesis on this now. At least I do the best that I can, cast it in a language in which one can try to reject that by data. But then, really, all I'm showing you is statistical correlation. Is there any strong physical argument that we can try to put out to explain this role of sun versus CO2, for example? Here's now my very simple pictorial picture to try to show you why the sun is more important than CO2. Okay? This is just a simple way of showing you with numbers. I won't even go too details in explaining what it means for now. But I think a better way to understand it is to use a cartoon analogy. Here we'll use a football analogy since most of us are familiar with American football. Just imagine that the Earth system is basically Tom Brady, the New England quarterback, right? Imagine the big gorilla in the climate system is the sun, right? The sun is, is represented by this big gorilla. And he's actually on diet. He's drinking some water, by the way, okay? He's on diet. And then CO2, of course, will be represented by Willie Soon. Willie Soon is a very greedy guy. He's been really eating a lot of steak and all that cheese, so he gained a lot of weight, which is that CO2 gaining 1.7 pounds, and then the gorilla is only gaining 0.2 pounds. And they're telling me that because I ate that much of a hamburger, I should be able to push this climate system so decisively up or down for the next 20, 50, 100 years, or even thousands of years. I've seen them doing simulation 10,000 years out, simply they want to melt the ice sheets, okay? okay? But that's the whole idea, right? Even if he gains so little weight, I mean, he's going to be still a very predominant driver of the whole climate system. There's no ifs or buts or doubts about this. Because I now want to show you that how they can insist to claim that CO2 is important. Here's very clever word tricks and the way of methodological framing your question. They essentially say that, well, you know, climate, what is climate? Oh, it's 30-year average, you know, of some weather, that's what they say. And then, you know, hey, we agree with the skeptics. Climate always change. Okay, so we should only talk about climate change. So this is the way they will cast their problem. They say, wow, CO2 is so big because the change in net radiation forcing is so big. And then the sun is ever so small. I don't even want to doubt, I doubt that number, of course, 0.2, because it could be as high as 1. But the problem is that in this way of casting your own, frame your own problem, I mean, clearly the CO2 is going to win. But guess what? In this picture, you're talking about climate system that has no weather, no season, not even climate, not even mean climatology in some sense. It's only about the change, right? So how could you ever beat these other guys? I mean, I just have a little problem with that way of framing the problem. Before I ended up now, I'll just show you two more things that may be surprising to some of you. Because people are saying, so what? You have observed the sun and all the measurements that you do is basically something at the top of the atmosphere. What happened to the solar energy when they actually reached the surface? First, I show you a very surprising thing that I got sent by Paul Dreesen, one of my colleagues who's sitting here, who said that he was really shocked at this particular chart. You all notice about the scale? This is showing a curve of a global temperature, of course, for the last 100 years or so. I mean, this guy's in the Earth Week of the, a diary of the planet is clearly a very, very scientific. They're talking about change of 9 degrees or 8 degrees Celsius since 1910, and then 5 degrees Celsius change in 1975. Obviously, this is a very wrong graph, of course. It's basically one factor of 10 missing from that. And just still plot anything that they wish, and then as if they can really talk to themselves and have another party. Now it's my final slide. Of course, this is just an answer to all this ultimate challenge. You've been talking about all this surface radiation at the top of the atmosphere. Do we have any evidence at all for solar radiation driving the whole climate system? This is all by accident. This is no amount of work you could think about to try to generate such a data. It so happened that we do have some very good quality data that is carried out by Japan Meteorological Agency that measure this something called the sunshine duration, just amount of sunlight, under clear sky, no haze, no all these things, no clouds, where amount of sunshine that reach the surface. That's really key because that's where you drive the whole system. And now we have an empirical proof, which is shown by the red curve here, connected by diamonds, right, going up and down. And then you show the northern hemisphere temperature. This is essentially the picture that Christopher, that you wanted to look at. And indeed, the explained variance is very, very high. I think at least one can be suggestive that, you don't have any empirical evidence for CO2 driving everything. And notice that this doesn't have to be CO2 changing, sun changing all by itself. This is changing of the cloud cover itself, actually, all right? And we have no way to tackle this question theoretically or whatsoever. It just so happened that you happen to have some kind of empirical data that help you to make a little heat wave towards this particular difficult questions. And with that, I'll stop now, and then perhaps later we'll answer some questions. Thank you.